rule. Okay, and I want to, if I want to chain these together, I want to chain them in such a way that I end up with dy dx. And so if I'm going to find dy dx, I'd have to chain them. Now actually it's multiplication, right? Does it make any difference in what order I multiply? It's kind of nice when you do it so that you can see them side by side, but you know, I could do du dx times dy du. It doesn't make any difference. It's nice when I do it the other way around, but it doesn't have to be that way. Because even here, my du's cancel. So let's see. Du dx is 5. Dy du is, that's actually going to be 1, isn't it? 2 times a half. So it'd be u to the negative 1/2. But again, can't stop there. Why not? Yeah. Yeah, x is my input, and I don't have it here. Okay, so I'd have 5 times, what was u? 5x plus 9 to the negative 1/2. Now, the rule for me with you is you never leave an exponent to be negative. So I would want you to go one step more and write it as 5 divided by, you can either say 5x plus 9 to the 1/2 power, or that's the same thing as saying 5 divided by, the square root, 5x plus 9. Either one of those I would be happy with. Okay. Now, again, to help you see that both of these, and actually the next slide takes care of what we're talking about now, but we're going to still continue to work on it. Let's do this. Let's do it the other way. Keep thinking about these not as two separate ways, but actually one way with two different notations. So if we're looking at the function y equals 2 times the square root of 5x plus 9, first thing I'm going to do is rewrite it, 5x plus 9 to the 1/2 power. And then if I look for the derivative of y with respect to x, come on, you can write it. There we go. If I'm looking for the derivative of this, again, my first thought is order of operations. What's the first thing I do in this function, and what's the last thing I do? The first thing I do is my inside function. The last thing I do determines my outside function. So what's my outside function? Who's saying what? I heard some good mumbling. I just need to, yeah, Aaron? So my outside function is taking the square root of something. Is that what you said? Yeah. Yeah, again, if I put some smiley faces here, and I ask you to find out what is, what's the derivative of 2 times something to the 1/2 power, you'd probably say it's 2 times 1/2 to the negative 1/2 power. Okay, again, if you need to, do something as silly as, not maybe literally, but figuratively, as little smiley faces in there. Just cover that stuff up, because it's just something to the 1/2 power. And what do you do with the derivative of something to the 1/2 power? Well, you do this, and subtract 1/2. Then it's going to be the derivative with respect to x of, and again, this is taking the derivative of the outside function, and now we have to take the derivative of the inside function. And so it's the derivative of 5x plus 9. Okay? Now, we should get back to the very same answer we got before. Should. Hopefully we will. What's 2 times 1/2? Just 1. Okay, so there's my 5x plus 9 to the negative 1/2. What's the derivative of 5x? Plus 9, rather. So we have just 5 there, because it'd be 5 plus 0. Okay. Is that the same thing we got before? Yeah. Now, which of these methods do you need to use? You really just need to know both. Certain problems are easier with certain processes. And some problems are easier if they're, to look at and to use this method with. Some of them, especially our application problems, are a lot easier if we can separate it out and look at the derivative of, each of the individual functions there. Okay. Like I said, we've already talked about this. I don't think we need to talk about it anymore. This is called the general power rule. If I ask you to use the chain rule, I consider this to be the chain rule. Why? Because this is the derivative of the outside function, and this is the derivative of the... Are we doing anything different than we were before? It's just using different notation. So if I ask you to do the chain rule, this to me is you also using the chain rule. Understood? The book may separate it out differently, so be careful with the web assign, but your answer should still come out to be the same on that. Okay. Well, let's just practice. Have some fun practicing here. Yeah, this one said use a general power rule. Well, yeah, okay, whatever. Okay. First thing we have to do, well, maybe the second thing we have to do. First thing I'm going to do is I'm just going to rewrite this. Okay. Trust me, not all these problems are square root problems. Seems like it, giving you 3 of them now in a row. Okay. What's your inside function and what's your outside function? That's the next thing to determine. And you can answer that by asking yourself the question, if I knew what t was, what's the first thing I would take care of? And what's the last thing? And so the first thing would be inside the parentheses. That's the inside function. The last thing would be taking the square root. That's the outside function. Okay, so if we're going to use the derivative, or find the derivative of this, you like stars better? Okay, we'll put stars over it this time. What is the derivative of something to the 1/2 power? The stars. Yeah, absolutely. And so, we'll just take 1/2 times whatever that is to the negative 1/2. Now, again, we're not going to use those in real life, so we'll go back here and just fill in that this is that amount. So this is your derivative of the outside function. What's missing? Yeah, derivative of the inside. This is the work I need to see on your papers. I need to see you put this step down, the derivative of the inside function. Remember, I'm not going to put this to the 1/2. The 1/2 power is the outside function. We're just working with the inside function. So we have, we can do some algebra along the way. We can say this is 2 times the square root of 2t squared plus 5t plus 2 times, yep, that's it, 4t plus 5. Now I've asked you to show me the derivative, take the derivative, and then show me at least 2 more algebra steps. Some of these problems, there's not going to be 2 more algebra steps to take. 4t plus 5 divided by 2 times the square root of that is just about as far as I think we need to go with this. Some problems there'll be more to do. Others, I always want a positive exponent. Yeah, always give me positive exponents. Okay, some of you I can tell are bored. You think this is so easy. You're wanting a challenge, aren't you? Right, Katie? You ready for that challenge? Yeah. You got this. Here we go. Okay, now, the challenge comes when we put more than one rule together in the same problem. What's one of the rules we're going to have to use? The quotient. Is that in our inside function or in our outside function? Inside. So the inside function is going to be using the quotient rule. What's the outside function needing? Yeah, well, it's going to be, yeah, the power rule. So we're going to use the chain rule on this one. Very good. Okay, so here we go. The derivative of y with respect to x equals, and again, imagine me putting smiley faces or stars or something over here. What would you do with something squared? Either 2 smiley faces to the first power. Okay, so it'd be 2 times something to the first. Well, what is that something in here? Yeah, you got to write the whole thing out. So I'm going to give myself a little more room here. So it's 2 times 6 minus 5x divided by x squared minus 1. You can put a 1 up there if that helps remind you. But that's the outside function you just did. Right here. Now, times the derivative with respect to x of what? Yeah, write it out just as you see me do it. And if you need to, give yourself a little bit of a hint. This is the outside function. This is the derivative of the inside function. Okay. This piece is pretty much done. I don't have to do any work on the outside piece at all. But the inside piece now, I have to use the quotient rule. So it's a good time to practice the quotient rule. Remember, you're going to write out those derivatives inside this. So it's the denominator times the derivative of the numerator, plus or minus. How do you know that? And again, do you have a method? Or are you just, hoping that you don't forget? As long as you've got a method. Mine is always that when I subtract, almost everything I do in the mathematics, if I subtract, if I'm dividing, I'm subtracting, like the terms like I explained on the video. Okay, so denominator, derivative of the numerator minus the numerator times the derivative with respect to x of the denominator, and I'm done, right? No, because I have to take it, everything divided by the square of the denominator. Okay, so in our work, we have 2 lines of showing the derivatives. One is showing the chain rule, so this is showing the derivatives for the chain rule, and then this one is showing the derivatives for the quotient rule. Keep my eye on that clock down there. Okay, so we've got 2 times the quantity 6 minus 5x, x divided by x squared minus 1, times x squared minus 1. Derivative of 6 minus 5x, negative 5. Okay, minus the 6 minus 5x. Derivative of x squared minus 1, 2x. All of it divided by x squared minus 1 quantity squared.